Hello, I'm Oleksandr from Ukraine. I'm a senior staff mobile engineer at Tide and GDE in Flutter and Dart. I worked as a backend engineer, wrote desktop apps and even games, but for the last 10 years I'm in cross-platform mobile development. During that time I worked with companies of any size, startups, mature businesses, companies that might be called enterprise, and even companies that we may call bloody enterprise. Today I want to share my thoughts about what is enterprise for me and if Flutter is ready for the enterprise. We will talk about what is good in terms of software development. I will show you some tools that might objectively prove that your codebase is fine, and in the end I will share my personal opinion on when to use the techniques I'm going to talk about today. I hope that you will learn something useful from this presentation. So, the question of the day is, what is enterprise at all? To answer this question, let's try to amplify all bad associations that might appear in your mind when you hear the word enterprise. The first association might be related to the complexity of the project, a huge mess that no one understands. When I was a backend developer, I worked with an airline company. I was responsible for a piece of the flow of ticket ordering. When I made my first changes and tested my piece locally, of course I wanted to test everything in a flow. I was not able to do so, but not because of some security or any other restrictions. There was no living soul in the team who could understand which modules need to be built and deployed and in which order. CI was the responsibility of another department. So for sure, everything cannot be just that binary. If you can compile the app on your MacBook, can it not still be enterprise? But there is definitely something in it. Let's think more. Is it about legacy? First of all, what is legacy? Michael Feathers introduced a definition of legacy code as code without tests. I love that definition. So, legacy code is the code without tests. Does it mean that enterprise code is the code without tests? It doesn't sound right to me. A code with too many tests? How much is too much? Okay, that's a topic for our investigation. In enterprise projects, everything should be documented. If 90% of all public classes are documented, is it enough for the enterprise world? Or maybe 50%? One more topic. There might be one more parameter, quality, but it's so hard to describe what is high quality. A few years ago, I asked the following question during interviews for team leads. Let's assume that my team wrote an app that your team is going to support. Our manager requested feedback on the codebase. What will you look at? The most popular answer was, unfortunately, well, I'll open the project and see whether I can understand everything. When you work on a project for a few months, most probably you can't understand everything in the codebase, which doesn't mean that the codebase is good. Another popular answer was about clean architecture. That's a huge topic. If you want to hear my thoughts on architecture, ping me on Twitter. That might be a topic for the next conference. But in short, in the modern world, clean architecture became a synonym for good architecture. Though the author of the term clean architecture, Robert Martin, crafted another term, screaming architecture. The architecture should depend on the task, not vice versa. When you see the architecture, you should see an app, not just layers. Sometimes I heard about tests. Well, it's definitely true, but from my perspective, far not sufficient. And many other criteria. That is a controversial question. In the interview, that was just the beginning of the conversation. Most of the time, the further communication was about subjective criteria. And subjective criteria leads to conflicts. Of course, not during the interview, but during the development process. Are there any objective criteria? Since quantitative measurements are essential in all scientific fields, there is continuous effort to bring similar approach to software development. The goal is to obtain reproducible and quantifiable measurements. Let's align on terms. Metrics are functions that return value of measurements. Hence, to measure something, you need to find a metrics function first. Metrics and measurements are often used as synonyms. Back to computer science. It's really hard to find objective metrics, mostly because everything is so abstract. Still, you may find many articles about different metrics. If you check Wikipedia, you'll find 28 items in the list of the most common software measurements. Well, that's a long list. When I thought about code metrics for the first time, I had two quotes in my mind. The first one you already saw: you can't manage what you can't measure. Here is the second one: not everything that can be measured should be measured. So, how to decide what worth to be measured and what doesn't? Well, you only need to read tons of scientific articles, compare proposed measurement functions, and find a way to get metrics. Or there is another trick. In Flutter world, we have the "there is a widget for that" phrase. In the enterprise world, there is an ICO for that rule. So I think you would not be surprised to know that there is a standard for that. ICO IIC 9126 was issued on December 19 in 1991. On March 1st, 2011, it was replaced by ISO EIC 25010. Here is what product quality consists of according to that standard: functional suitability, performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. Each of these topics is worth a separate presentation. As we are limited in time, let's focus only on one of them: the maintainability. The maintainability characterizes the ease with which a software product can be modified. In other words, it shows how quickly you can fix bugs or introduce change requests. Here is a picture from Wikipedia. In the standard, the maintainability consists of testability, analyzability, and modifiability. All of them break down into more topics, but today we are interested in the lower level. This is a level of metrics. Let's review these metrics and try to find appropriate tools for measurements. We'll start with rule violation. In the standard, there are minor, major, and critical rule violations. Violations are language specific, and you already saw the report on the metrics right in your IDE. Though in Dart we call them info, warning, and error level violations. Info violations are safe to ignore, warnings should be fixed, and errors must be fixed. I think you all know a tool to measure these metrics. It's a static analyzer. When you create a new Flutter or Dart project, you may find a linter in its dependencies. It has a set of rules that were handpicked for your convenience. This list is opinionated. As there are more than 100 rules in Dart's static analyzer, there are many linter packages with a different list of enabled rules. If you are interested in this topic, I highly recommend you to check a post by Mike Rydstrom called Flutter Linting Comparison. There he compares different linters, so you may go and find one that you think will work the best for you. If you don't want to bother, my personal recommendation would be to go with a very good analysis package. Or, if you want to fine-tune the linter, spend a day reading linter rules and creating a set of rules specific for your team. Most probably you will find so many gems in the analyzer that you didn't know about. So, speaking of rule violations, I think the tooling is quite good. Let's talk about next metrics. To illustrate some metrics, I use the source code of my own BDD widget test package. Advertisement here: if you don't yet test your app, you should definitely check it. The simplest thing you can do with the source code is to count lines. That's a super important metric if someone is paying you for the amount of code you write or the amount of code you didn't write. Just kidding. You even don't need to know Dart to say how many lines of code you see here. So, how many lines of code do you see here? I will give you a second to think. In fact, that's a tricky question. The answer might be different depending on which lines of code we are talking about. One might say that this is the file with code, hence all lines in this file are lines with code. Someone might argue that empty lines should not be counted. Let's hear different opinions on that topic. For example, there is a clock utility with 90 contributors. At least 90 people worked on a utility that just counts lines in files. I told you that this task is not that obvious. Let's run this utility and ask it to count lines for us. 10. If you found 10 lines of code when I asked you to count them, congratulations, you have counted physical lines of code. There is nothing wrong with physical lines of code, but do you remember our idea? We wanted to collect the logical lines of code. So we need to find another tool. How about that one? You may add Dart code metrics as a dev dependency to your project and get a bunch of awesome additional analyzer rules, so it might be useful for the previous topic, static analyzer. But today we are more interested in observing metrics. To get them, you may install Dart code metrics as a CLI tool. And by using this command, you will be able to generate an HTML report. In this particular case, I'm generating a report for all files in the lib folder. That's the report for a single file. So many interesting stuff there. We will talk about most of them a bit later, but for now we are interested in the second parameter at the top. The source line of code is equal to 3. What? How is that? Simple. Line with imports are not really lines of code. They help the compiler to find required entities and have nothing in common with business logic or any logic. On line 5, there is a method declaration. You may write it in many different ways. In a single line with line breaks after each parameter, like there, you may put a curly brace and async keyword at the same line where the last function parameter is declared. And the same is about the line with finder declaration. You may put everything in a single line or maybe add a trailing comma at the end. So many ways to write the same code. That's why developers agreed to count all such cases as a single line. So line with the function declaration, line with finder, and line with the expect invocation. 3 lines of code in total. Those of you who said that there are 3 lines of code, you are awesome. You know how to calculate the source lines of code. But our goal was to calculate logical lines of code metric. Okay, if that metric is so non-intuitive, let's find its declaration. LLOC measures the number of executable statements. What is a statement? It depends. Depends on the language. For C-like languages like Dart, it might be the number of statement-terminated semicolons. Alright, back to code. How many statements do you see here? Do you remember it's the number of semicolons? I see 4. Half of them are in imports, which we completely ignored as code lines in the source lines of code calculations. And with this definition, we skipped the function declaration, so maybe we may count it as a line of code. By the way, on line 10, there is AND operator. Should it count as a statement? That's the question. I don't know. This metric is supposed to be language specific, but the exact declaration is so unclear, so I'm not sure whether we may say that we all are aligned on it. That's why I think that we may almost say that we may calculate this metric. To make things a bit more pragmatic, if you don't plan to really write the app that complies the standard, just measure the source lines of code. Next metric, NLE, which is a nesting level. This metric is intuitively clear from its definition. The nesting level of the method is expressed as the depth of the maximum embeddedness of its conditional, iterational, and exceptional handling block scopes. For a class, this metric is calculated as the maximum nesting level of its methods. Here is another piece of code from BDD widget test package. What is the nesting level here? I'll give you a second to think about it. Well, I see one nesting level here in if statement, and maybe one nesting level is the function itself. Okay, so let's find a tool to validate that. Why not Dart code metrics? I told you, you can measure many things with it. This is not the last time you will see this package in this presentation. According to the report, the maximum nesting level for a function is 2. Well, that looks accurate to me. So we may tell that we may measure the NLE metrics. Let's proceed to the next one. The numpar stands for the number of parameters. Well, that's another metric that is clear from the definition. It's the number of parameters of the method. Look at this method declaration. If I'm not mistaken, there are 5 parameters here. Let's find a tool to validate that. Oh, I know one. According to the report we generated before, this function has 5 parameters. Nice, that was easy. What about next metrics? MCCC is a McCabe's cyclomatic complexity. The complexity of the method is expressed as the number of independent control flow paths in it. This metric quantifies the complexity of a program. Programs with higher McCabe's number are likely to be difficult to understand and hence have higher chances of containing bugs. I bet you know already which tool we may use to measure this metrics. Yes, it's the good old Dart code metrics. The cyclomatic complexity of this function is 3. It is worth mentioning that the complexity of a class calculates as the sum of the complexities of its parts. This particular file has the complexity of 8. Half is done. Let's see what's left. Clock stands for command lines of code. The only question here is, should it treat documentation comments as comments? And the answer is yes. You already solved this file. It's easy to guess that the number of comment lines here is 1. So let's find a tool to measure that. To measure clock, you may use clock. That was easy. Let's see what else we may measure. CD. CD stands for the comment density. I didn't find a tool to measure comment density, but it might be easily calculated by this simple formula. So, to get a comment density, you just need to take the number of comment lines and divide it by sum of comment lines and lines of code. So for this file, we'll take 1, divide 1 plus 10, 11, and get 0.09. That means that 9% of this code is documentation. Oh wait, lines of code. Which lines of code? Of course, not the physical ones. We have source lines of code. For this file, the metric was equal to 3, so 1 divided by 1 plus 3 is equal to 0.25. Look how changed this metric. How cool is that? According to the standard, we need to take logical lines of code, the ones that we struggled to calculate. So in the end, this metric will depend on what you call a line of code. We marked logical lines of code as almost done. As CD depends on it, we'll mark it as almost done too. Next metric. CC stands for, no, not code coverage, clone coverage. The clone coverage indicates the percentage of code lines that are covered by at least one clone. It can be interpreted as the probability that a random change to a code line needs to be made in at least one other clone instance. Oh, that would be a tough one. First of all, we need to find clones. What is a clone? Clone is the exact code duplication. Here I found a clone. A few lines starting from line 22 and lines starting from 47 are identical. So we need to find a tool that will help us with code duplicates. There is a static source code analyzer called PMD. It might be used for so many different purposes. For example, it is possible to find code duplications with it. It's so awesome that it even supports Dart. To get code duplications in the console, you may use pmd cpd command. But to make it more fun there is a GUI for that. You may run it with this command. Here is the example output. Oh look, 2 duplications in stringqtils.dart file for 24 and 23 lines and 16 lines duplicated in generic steptest.dart. Oh, that's not good. Now we know the number of cloned lines. To get the metrics, we need to divide this number by the number of total lines. You see the problem, right? It's about what is a line of code again. In the end, this metrics might be measured when we agree on what is the line of code. Almost done. CBO stands for coupling between object classes. It measures the number of directly used other classes by inheritance, function call, type reference, attribute reference, and so on. Classes with high coupling are harder to test and they are more sensitive to changes. Unfortunately, I didn't find a tool to measure this metric. AD stands for API documentation. It's the ratio of the number of documented public methods and classes to the number of all public methods and classes. Well, it's easy to find which public methods or classes lack documentation with Analyzer. I didn't find a way to calculate that metrics. The good news is that it will be 1, which is good, if you make your analyzer complain if something publicly available is not documented. NOAA stands for number of ancestors. It's the number of classes and interfaces from which the class is directly or indirectly inherited. Sounds simple, though didn't find a way to calculate it. NII stands for number of incoming invocations. It's the number of other methods which directly call the local methods of the class. Unfortunately, didn't find a way to measure it either. So, speaking of standards, we may calculate the majority of metrics to make the decision on how maintainable the codebase is. Though when I hear the word maintenance, the first association I have is tests. What about tests? Of course, they are essentials. The main test metric is test coverage. It is the percentage of the code that is covered with tests. How can I calculate it? Fortunately, this is super easy. You just need to run test with the coverage option. With that option, it will take much more time for Flutter to run tests, but it's worth it, because in the end, you will get a lcov.info file. Let's look at this content. Oh, that's not really helpful. To work with this file, we need to install a lcov utility. Now it's much better. Speaking of metrics, that would be more than enough already. But as a developer, I'd love to see what exactly is covered, so that it will be easier for me to improve these metrics. There are many ways to do that. For example, you may generate an HTML report. That is what it looks like. Here you may see an overview of the project with the code coverage for folders and files, or have a closer look to a specific file and see which lines are covered. That report is super useful on CI, but during the development time, I'd love to see it right in my IDE. If you, like me, prefer VS Code, you may install a coverage gutters plugin. It will add two useful things to your IDE. In the status bar at the bottom, you will see the percentage of coverage for this file, which is super useful. And in the editor itself, you may see light green indicators in front of code lines. That means that these lines are covered with tests. Lines that are not covered with tests will be marked red. If you're an Android Studio user, things are even better. You may run tests with coverage without any plugins by just pressing a button between the debug and hot reload buttons. After Android Studio runs tests, you will see the same green indicators and percentage of covered lines in the project view. Tests are done. Do we want to track the dependencies? In short, yes, but there might be different kinds of dependencies. There might be dependencies inside a package. That's about coupling. As I told you already, unfortunately, I didn't find a tool to measure coupling metrics, but there is a great package called Lacos. It's a command line tool that can visualize internal Dart library dependencies and compute useful dependency graph metrics. BDD widget test package is too small to make it interesting to look at these metrics, so I downloaded a pinball app source code from Google I/O. If you run this command, you'll be able to see a dependency graph in graphviz format, which is not interesting for our goal. What is interesting is the last line of the output, a couple of magic acronyms. Fear not, I will not torture you with more code metrics, but if you're interested in understanding what's going on in the project, you'll have to track them. In short, the dependency graph contains cycles, which is not good, but overall everything is fine. You might be interested in tracking external dependencies of your packages as well. To do that, you may just count the number of dependencies in the pubspec file. Flutterpub depth command will show you the whole list with subdependencies. To make it more fun, I recommend using a pubviz tool. Here is a part of the visualization of pinball package dependencies. So many tools. Maybe there is one best tool that everybody in enterprise uses. Well, there is no official tool for metrics, but almost all companies I worked with used SonarQube. It's free, so you may go to sonarcube.org and grab yourself a really powerful instrument. Unfortunately, it doesn't work with Dart. But not everything is lost. You may download this wonderful Sonar Flutter plugin for SonarQube that will add Dart and Flutter specific functionality to it. Next, you will have to create a Sonar project file in your project folder. Here is the example of one. And then you'll need to install and run a Sonar scanner tool. And voila, a dashboard with analyzer report, code coverage, code duplications, and some other metrics. Of course, that dashboard should not be stored on your local machine. The bad news here is that I didn't find an existing service that hosts SonarCube server with the Dart plugin. The good news though is that if you are working on that scale, most probably you have a department that maintains a bunch of similar tools, maybe even SonarCube. So it's relatively easy to create an in-house solution. From my experience, sometimes SonarCube is too much. You may use simpler things. Trends are more important than values. Usually you are more interested in whether the codebase becomes better or worse. For that, you may collect metrics from tools that I have shown you and store them in the repository. And remember, it's much easier to prevent some degradation in the codebase than to fix it. You need to set up tools that will not allow introduce any issue, but not everything that should be measured might be measured easily. So if you create a team manifesto with all agreed guidelines and will follow them, you are good. Just a Confluence page, unpopular opinion, but I prefer Markdown in Git. Just a page with agreements will improve the codebase dramatically. We are almost done, and before going to conclusions, I'd like to give you a piece of advice on when to apply all these tools I talk about. For all sizes of projects, I encourage you to have zero tolerance for everything that this analyzer might find. It's so easy to set up one. If you don't want to bother, take the existing settings. Tests are essential. I would not set any coverage target for small projects. Just cover at least happy paths. On medium and large scale, we need to have a quality gate. Why not 100%? Because I don't see a reason to fight with tools, but that's a separate topic. Speaking of ICO metrics, I would not track them on small projects. For medium-sized projects, I'd focus on complexity and code duplication. Large projects are harder to maintain, so I'd take all help from metrics I could get. A team manifesto is not needed if the project is small. Some basic agreements are required though when things become serious. On large scale, usually everything is well documented and described. In small projects, usually we don't have a problem with dependencies because there are only few of them. On medium-sized projects, I'd track external dependencies. By the way, I'm not proposing limiting them, I'm just recommending tracking them. On large scale, we would have to track internal dependencies too. And the last one, the way I propose to track metrics. On small projects, you'll have an analyzer in your IDE. Don't forget to run it and run tests too on your CI and you are good to go. On medium size, there must be some visibility, so consider collecting reports and using badges. On large scale, I'd want to say we need something better like SonarCube, but the tooling is just not there yet. Okay, conclusions. Returning to the question I asked during the interviews, is it safe to say that the project with good metrics is a good project? Not necessarily. It still could be a mess, but what are the chances that it's a mess with good objective criteria, love coupling, good test coverage, limited amount of dependencies with guidelines? No, chances are extremely low. Flutter is great for enterprise. So is native, so is Xamarin, so is React Native, so is any framework or language. Because enterprise is not about the framework, it's about the way you treat your codebase. Tools are not quite ready yet though. Analyzer and Dart code metrics are the best we have. By the way, Dart code metrics are super slow on large scale. To make a good picture, you'll have to find and combine many tools, which I hope might be easier for you after this presentation. The very last words. Working on a new project, do it right. Working on legacy, do it right. Just be a bit more tolerant on whether to fail a build on CI. And create the habit of tracking metrics with the team. Thanks. That was a controversial topic, so if you want to argue with me, write me on Twitter. Those of you who watch that now, let's discuss.